Hi there, welcome to another lecture for chemistry. Today we're going to be talking about the periodic table and the history of the periodic table, learning about some of the scientists and some of the ways that some of these, the organization of the periodic table was developed. Okay, so let's talk about our objectives here for the day. And we are going to be covering the history of the periodic table. Describe the historical development of the periodic table and identify the organization according to atomic number and properties. Now, I think this sounds kind of like, no, that's boring. No, this is actually kind of interesting. It's interesting to go through and discover how these people came about with some of these discoveries. I can explain how Mendeleev organized his periodic table and how Moseley modified it. That's our criteria for success. I'm also going to tell you a little bit about a guy named Newlands, who also did some really interesting things there. Okay, so it's just kind of a funny comic here. Having flunked 3 consecutive chemistry tests, Brad got home one day to discover that his parents had wallpapered his room with a periodic chart. So, you never know what's going to happen if you don't study chemistry, so I make sure I be studying. So the first guy we're going to talk about is John Newlands. Now, this guy is actually not in your textbook. He was actually in textbook that I had when I was growing up and learning chemistry, and it's always made an impact on me, and so I like to talk about him. Newlands was the first to order the elements by atomic masses, and he's one of the first guys to actually talk about periodicity. Nobody had ever really talked about the periodicity of the elements until him. He came up with something called the law of octaves in 1865. You can see his periodic table down here, and you can see that he's got some elements, definitely not the elements in the order that we would now have them, right? Oxygen's number 7. You can see there's no helium. There's no neon, right? So there's elements that haven't been discovered yet, like the noble gases. And then he's got some stuff where he's got a couple different elements in the same places. When he came up with this chart, he was pretty much ridiculed by a lot of his contemporaries, because one of the things he didn't do is he didn't make allowances for predicting elements that had not yet been discovered. And that's got, one of the things that the next guy, Mendeleev, did do. And so, they didn't even publish his paper. His paper was more of a theory instead of actual data. And so they were like, yeah, we're not going to do that. But even though he was ridiculed, and this was back in 1865, by the time 1887 rolled around and they'd actually kind of figured out, this was, there were some things here that were true, he received the Davy Award in 1887 for, his preliminary work on periodicity. I think it's important to understand that perseverance is important, and then sometimes ridicule is going to happen. It doesn't mean you're necessarily wrong or that you have a completely wrong idea. You might have some good ideas that can then be implemented by other people. And again, I really like to think about this, because he likened his periodic table to music, the octaves and the piano. Now, again, we now know that they actually kind of have 8 and then repeat instead of 7 and repeating. But, I think that when we study other subjects, when we do things like music and sports and, just various different parts of our life, and we're well-rounded individuals, a lot of those things can really tie in and help us to make discoveries. If we have a liberal arts education and we understand history and music and art and all that kind of stuff, and we can bring all that stuff together, even in science, you can make some great discoveries. Anyway, so I like Newland because of that. There's some, interesting stuff on Mendeleev's periodic table. You can go watch some of these things. I'm not going to watch them now, but you can check out SciShow. They've got some good videos on Mendeleev and his periodic table. Here's Mendeleev, and he organized the first table that was accepted by the Royal Society of Chemistry. He organized the things in order of increasing atomic mass much more successfully than Newlands did. He noticed that we were repeating similarities in the elemental properties, and so we now call that the periodic law. And again, notice that he did his work and published it in 1869. Newland had done it in 1865, so he was a little bit of a precursor here. But the big thing about what Mendeleev did was he left these empty spaces and predicted the properties of undiscovered elements. So he was able to say, I think what's going to happen is we're going to discover such and such an element, and it's going to have these properties. And he was right. And again, you can go back and watch that video by SciShow, and you can see some of that stuff there. Okay, so what we want to see here is that Mendeleev's table still had some issues, right? We had the elements organized by atomic mass. Remember, atomic mass is the number of protons and neutrons, right? The average number of protons and neutrons in an atom. And so we had organized things by atomic mass, or he had, and I wasn't there. And he had figured out, something that was a pattern, but there were still some gaps. There were still some problems that didn't fit. They weren't in the right order. If you actually put them in the order by atomic mass, and it kind of swapped them out in one place, and they shouldn't have been. For instance, if you look at iodine, you're going to see that its number is not quite in the right spot. And if you order them by atomic mass, it actually puts it out into the wrong place. We still hadn't figured out why the properties were repeating periodically. What was the main thing that was causing these to do this? Now, remember that these guys are figuring out what the periodic table looks like, and they didn't even know what a proton was, right? Like Rutherford figured out what the proton was in 1911, and we hadn't yet figured that out when they were figuring this periodic table organization out. So kind of interesting that they were able to do some work like this without understanding even what was causing the arrangement to work out the way it was. Okay, so let's look at the next guy, Henry Moseley. Now, Henry Moseley is kind of an interesting story, and I think you're going to find out that his connection to history is kind of interesting and kind of impacts, or could impact you in some ways in the future as well. He showed that the patterns were fitting better when they organized by atomic number. Okay, now he did his graduate work, and he was a pretty, smart up-and-coming scientist, and he was doing some work in the lab. By the time he was, in his graduate work, he'd discovered a couple really key things. Like he did this while he was in graduate school. He hadn't even, graduated from graduate school yet, right? And he figured out that you should maybe organize things by atomic number, and he did that because he used a new type of X-ray spectroscopy, which somebody else ended up getting a Nobel Prize for later on, because he didn't get a Nobel Prize for any of this work because he enlisted as a patriotic citizen in the army, and he died at Gallipoli in World War I in 1915. So he was 27 years old when he died. And after he died, there was a kind of like an outcry, I guess, by some. And at that point, the War Office in Britain changed the recruiting policy, so scientists would no longer be sent to the front lines. He was shot through the head, presumably by a sniper, and he wasn't able to contribute anymore to his scientific, community because he was dead. Isaac Asimov, who was a historian and science fiction author, later asserted that in view of what he might still have accomplished, his death might well have been the most costly single death of the war to mankind generally. And I think that's kind of an interesting thing to think about. So, today recruiting possibilities, they send, scientists to the lab and they help, make weapons and things like that, instead of sending them to the front lines, at least if they're in a war situation. At least that's what they changed it to then. So pretty fascinating. All right, so you can also do a little bit of research on, and you can watch this video if you'd like, on different ways that the periodic table is organized. So we have our standard periodic table that, we show you over and over again, and you just kind of have that's your, your standard. But, a lot of different people have organized it in different ways. We have one here. This is just like a method where you can fold and so, show certain groups. You can say, hey, I just want to look at the representative elements. I just want to see those representative elements instead of all of them. If I could fold it the right way. It's a little bit above my IQ apparently. So you can say, hey, these are the representative elements and you got to figure out, different ways to organize it. It's really, kind of a cool little tool. But there's so many different ways that people have thought of to organize elements, and you can watch this video if you'd like for fun. It's about 10 minutes long, and you can go to YouTube and look up, 5 periodic tables we don't use. It's another SciShow thing, but it's kind of cool to see the different types of periodic tables that we have. Some of them are in spirals, and it's neat to just kind of get a picture of what that whole thing is like. So anyway, fun stuff. Can we do these objectives? Describe the historical development of periodic table. Yeah, we can now see how it kind of changed through time. Identify the organization by atomic number and properties. Yeah, so remember, Moseley was the one that said, we should organize by atomic number. Don't forget that. Okay, remember that atomic number is the number of protons in the atom. And so he said, let's not do it by mass, let's do it by number. And then when you look at iodine and you organize iodine by atomic number, then it stays in line with its similar properties, and it's in the right place. So what are your criteria for success? Can you explain how Mendeleev organized his periodic table and how Moseley modified it? Yeah, you can. And you can even tell me a little bit about John Newlands, and a little bit about the history and how recruiting in the war has changed, and that Moseley was taken from us through war, which is sad, and all sorts of stuff. You can tell me a whole bunch of stuff now. All right. Well, that's it for today. Thank you guys for watching. I hope you have an awesome day. God bless you.